Moving on to relative atomic and molecular mass. Relative atomic and molecular mass. Picking the first one, which is relative atomic mass. The symbol for relative atomic mass is RAM. What is relative atomic mass? Relative atomic mass is the atomic weight of an atom compared to 12 grams of carbon-12 isotopes. Okay, let me explain what this actually means. As you know, that atom is known to be called the smallest indivisible particle on Earth. Smallest indivisible particle on Earth. So in that case, atom cannot be broken down into other particle, and atom is very, very minute. So it is impossible for you to find the mass of an atom by weighing it with an instrument or with an instrument. So an atom cannot be weighed. So because of that, the best way they could do an atom or to measure the weight of an atom is for them to compare the weight of that atom to what we refer to as carbon-12 isotopes. So the weight of an atom is compared to 12 grams of the carbon-12 isotope. Okay, let me give an example of what this actually means. Let's assume I want to know your height, and I don't know. Okay, sorry for using you as an example. Let me use another person. Let's try to see we have someone that's a little bit shorter, which is A, and we have someone that is tall, which is B. At D being, I actually know that this person is 6 meters tall by height, but I don't know the height of this person. But I can get the height of A if I compare it to my B. So I will know that my A can never be greater than 6 meters tall, but rather can fall between 4 to 5 meters tall. And that's how they get the atomic weight of atom. We don't really know the weight of an atom, but because we compare it with a substance we call carbon-12 isotopes, but the 12 grams of carbon-12 isotope comparing to atomic weight is what we use to determine the atomic weight of every element. Okay, let's go to what we have. On the chart here, we have elements and their weight. I will give you a logic you can use to determine elements and their weight. But for now, let's look at this example. This helium, and on helium, we have the atomic number to be at the bottom, which is 2, but the weight is written at the top, which is given to be 4. This boron, the weight of boron is known to be 11. This is carbon, is known to be 12. This phosphorus to be 31. Silicon to be 35.5. Argon to be 40. We have aluminum, the weight is given to be 27. So let me teach you the logic on how you can determine the atomic weight of an atom without memorizing it. Okay, moving to the logic and formula. Let's assume I want to find the atomic weight of sodium, and likewise I want to get the atomic weight of oxygen. The very first thing you have to consider is the atomic number. The atomic number of sodium is 11, while the one for oxygen is 8. Now, if the atomic number of sodium is 11, 11 is an odd number. What an odd number? This is a number that they cannot be divisible by 2 unless there will be a remainder. While the atomic weight of oxygen is 8, and that kind of number is called an even number. What an even number? This is a number that when they are divisible by 2. So in this case, anytime we found out that an atom contains an odd number, we try to multiply the atom by 2, then we add 1 to it. Immediately, we've gotten the value for their atomic weight. Okay, let's look at it. 11 times 2 will give you 22. 22 plus 1 making 23 grams per mole. So that's the weight of sodium. Okay, let's consider oxygen. Considering oxygen, oxygen is 8. Because oxygen is an even number, I only need to multiply that by 2. I'm not going to add 1 because it's an even number. So in that case, 8 times 2 gives me 16, and that's 16 gram per mole. So this is simple logic we use to determine any weight of an atom. I'm also going to give you some exceptions. Okay, let's give more examples. Let's consider aluminum. For the case of aluminum, and also let's consider magnesium. Aluminum is 13, magnesium is 12. Okay, the atomic number of aluminum is 13, and it's an odd number. I told you multiply by 2, then you add 1. When you multiply 13 by 2, that's 26, plus 1, that's 27 gram per mole. But when you look at magnesium, that's 12. So 12 times the 2, but I'm not going to add 1 to that, and that gives you 24 gram per mole. So this is simple logic towards getting the atomic weight of any element. That means the first 20 elements. Let's give exceptionals. There are some elements in the first 20 elements that are exceptional. The first one is hydrogen. The atomic weight of hydrogen is always 1 gram per mole. The second one is nitrogen. The atomic weight of nitrogen is always 14 gram per mole. The third one is argon. Argon is always 40 gram per mole, while the last one is chlorine. Chlorine is always 35.5 gram per mole. So these are the exceptional that we need to just memorize. For the rest, we can apply the logic for the first 20 elements.